What is up, Flutter devs? I told you that after we got through all of that tedious bitmap work, it would be back to some coding challenges. As a reminder, coding challenges are actually not necessarily content, but sketch code that was written by Dan over at the Coding Train in his video series. And I asked him before I began any of this work, I said, Dan, can I try to recreate what you've created in your coding challenges, but with this Flutter port of processing? And he said, hey, go for it. So today we're going to continue with another one of Dan's coding challenges. This one is going to be what's called random walker, and let's take a look at what that actually means. This is going to be a very, very simple exercise, assuming things go right. And that's the reason that it's going to be simple, is because if things go wrong, we need to go fix them. But if things go right, it's going to be very, very simple. Let's take a brief look at what we're going to be creating. So here's a video where Dan creates this random walker. What we have is a small little white dot that just moves in different directions. But as it moves, you see the path that came before it. So let's watch this very briefly. So you see that little dot moving around, just a random direction. And the reason that we had to wait for this very simple exercise is because up to this point, we didn't have the previous bitmap frame. We could have remembered all the places that this little dot moved, and then we could repaint it on every frame. But really all we need to do here is add one more pixel to the previous frame. That's really the natural way to do this. And now we should be able to, unless we missed something in our bitmap work, which we're going to discover now. This here is all the code that it took Dan to implement that random walk. We size the canvas 400 by 400. We start in the center of the canvas. In this case, Dan gives a background color at the very beginning. And the reason that the background color is given in setup is so that the background is not filled on every draw frame. Why? Because in every draw frame, we want to add one pixel on top of what was there in the previous frame. If we clear the whole background out, then we're going to clear out the previous path. And then it's just going to be a dot moving around. In fact, we'll probably do that first so you see what the difference is, and then we'll move the background call up here into setup. As for each frame, there's a white stroke of weight 2, which is drawn at the given X and Y point. Then there's I guess a random that says R, which seems like it's for radius, but maybe it just means random. It's used down here to select a direction. Up, left, right, up, down. One of the four general directions. This is all that's involved. And we're going to see if this works with our current bitmap implementation or not. And if it doesn't, we'll try to fix our implementation. So I already have a sketch set up for us. It's the bare bones, what you're used to seeing by now in these videos. And it's visible right here. Now this canvas is just 100 by 100. So let's begin by setting it to 400 by 400. And this is, we made this a method, I guess. And I guess we said that they're named parameters. Okay. Save that. Okay, now we're 400 by 400. And then we also need an X value and a Y value. Say late int X, late int Y. Late because we're going to give them, once we give them values in setup, they're always going to have values. So beyond that point, they're non-nullable. And we can generalize the assignment by saying X is S dot size, or I guess S dot width, and then Y, oh, sorry, that we want it in the middle, right? So that's divided by 2. We need to round that. And then Y is S dot height divided by 2 dot round. Now, like I said before, we're going to start by painting the background here in draw just to see what a single dot looks like. And then we'll try taking the background and moving it up into setup. We'll go with a relatively dark gray. And then we want S stroke. The color was white. And a stroke weight. What was this? I think it was 2. And then we draw the point. And I actually can't remember if we hooked up point to use the stroke paint or not. I may not have done that. X 2 double, Y 2 double. Let's just see what that gives us. Okay, there's a little point right there. So I think that stroke weight, I think strokes are not being applied to the point drawing. Let's jump into point. Here's our point method inside of our core drawing implementation. And so I'm just always drawing a 1x1 rectangle when probably the more appropriate thing to do is to draw a circle. And that's offset at X, Y. So center, radius, paint. Okay. I guess the radius will always be 1. Maybe it should even be 0.5. We'll go with 1. And here I get rid of the stroke. We probably don't want to get rid of the stroke. We probably want to draw with the fill. You know, I should probably just go back to the processing documentation and find out, see if it actually tells us what this is supposed to do. Draws a point, a coordinate in space with a dimension of 1 pixel. The first parameter is the horizontal value. Second is the vertical, fine. Okay. Use stroke to set the color of the point. Point appears round with the default stroke cap and square. Points are invisible with no cap. Using point with stroke weight or smaller may draw nothing to the screen. You know, I'll probably have to go play with this. Documentation is not clear enough for me to understand what the intended behavior is. I'll have to go play with it. So I'm going to undo this. And given that all we want is a dot on the screen of a reasonable size, all we have to do is say fill with white and then draw a circle at X, Y with a diameter of 2. And once again, we have to say 2 double. Let's save that. Now that looks black. Now it's white. Let's pump up the diameter a little bit to 4 pixels so it's easier for us to see. All right. And now we want to move this in a random direction. So the way that the random direction was accomplished in Dan's sketch, we generate an integer between 0 and 3, 0, 1, 2, 3, and then we just do a switch statement to pick the direction. So we'll say random direction equals random. I need to import that. Next int, the max value is 4, which should be exclusive so that we only get 0 to 3. Exclusive to max exclusive. So we're going to get a value between 0 and 3. Then we can say switch on the random direction, case 0, break, case 1, break, case 2, break, case 3, break. And it doesn't really matter what direction we choose for each one because it's all random with an equal distribution. So here we can say x plus equals 1, x minus equals 1, y plus equals 1, y minus equals 1. Let's save that. All right, now you see we have this random motion similar to what we saw in the video. The thing is, though, we see its current position, but we don't see where the dot was beforehand. And one of the reasons for that is because we are redrawing the entire background on every frame because of this line right here. So let's take that line. And this is the part, I can't remember if I did the right thing in terms of redrawing the previous frame when I did the bitmap work. So this may actually be broken. And this is one of the things that I wanted to find out by doing this exercise. So if we'll size the sketch or the canvas up here in setup, we will immediately paint the background one time, and then we'll never paint the background again. Let's save that. Okay, and we get the same thing. And that's because I think when I implemented the bitmap drawing, I forgot to always draw the previous frame. So let's go fix that. Here in core, now we're back in the implementation of processing. Let's find, where should we do this? Maybe on draw. So that every time, okay, so here's one problem. We don't want to do this. We don't want the background color to be drawn on every frame, but I don't even think that's the primary issue. It's definitely some kind of issue. We want background to immediately paint. And it should be. But for some reason, if we don't paint it in draw, we don't get it. So let's see what we have going on here in do setup. So here we paint whatever the current background color is in setup, but we're losing it. Let's see. Why would we be losing that background? Well, first, let me do the part that I thought we needed to do here first, which is every time we draw, obviously we want to execute whatever's in the draw method. But before we do that, we actually want to draw the previous frame. We want to say canvas draw image, and we want to use the published image. The last image that we rendered to the screen, we want to draw it again immediately so that all future drawing happens on top of it. And that's at offset 0 with this paint. And what we want to say here is if published image is not equal to null, and I think this is going to complain from a nullability standpoint, because I said published image is initialized late, but it hasn't been initialized yet by this point. Let's see if this will compile. Yeah, so it's not liking that. I think what we have to say in that case is that this is not initialized late. We have to go ahead and make it truly nullable, which means we have a number of other things to fix. Any place that we access it and assume that it exists, we're going to have to explicitly say that it exists. And here, I'm going to wrap both of these and put an exclamation there so that source image, we don't have to apply it for every use of that term source image. And these are unfortunate uses because by the time any of this code runs, the published image definitely exists. But because there's one place that we use it where it doesn't yet exist, we're stuck making it nullable everywhere. And if anybody has a suggestion to improve that, I'm open to hearing it, but this just seems to be one of the negative side effects of non-nullable types. Let's see, isn't there an issue here? No, I guess it's just these breakpoints that shouldn't be there. Okay, let's go back to where we were. So the very first thing we do before we execute the next set of drawing commands is we paint whatever was previously painted. Let's save that. Let's do a hot restart. Okay, well, somehow that solved both of our problems. I'm not sure quite exactly how. I think maybe the very, very first frame doesn't have the background, and then after that it does. Let's see if we can kind of capture the first frame. It's hard to say. What happens if we say s.noLoop and do a hot restart? No, I still got it there too. Okay. At some point, there might be a little race condition there that comes back to bite us. But for now, this is what we were going for. So notice that the fact that we keep a bitmap around for the entire sketch, it's like an implicit data structure on our behalf. Because if we wanted to draw this normally in Flutter, imagine that you were trying to draw this with your custom painter. Every frame completely erases your previous frame. So if you wanted to implement this very simple behavior using a custom painter, you would have to save every position that this little dot ever occupies. And every single frame, you'd have to draw every one of those points, which also has an interesting downside because every time you add a point, you require more memory and you require more drawing commands per frame. But because we have this bitmap sitting here, we have exactly the same amount of memory and exactly the same number of drawing commands on every frame. Now, it's true that we have to process the whole bitmap, but every frame, that bitmap is exactly the same size, and it's just sitting there in memory, right? Exactly the same size. And all we do is draw one pixel. We fill one pixel of color. But if you do this with a custom painter, if you do this with the normal Flutter render pipeline, like right now we might have, I don't know, 500 dots on the screen. You would have to draw all 500 dots every single frame. Eventually that becomes a kind of performance issue. We don't have that problem here. Our performance is exactly the same on frame 0, frame 10, and frame 10,000. And this is when we begin to explore some of the interesting things that bitmap-based rendering gives us. It can change the performance characteristics. That is Random Walker. And again, thanks to Dan who wrote this code. See, here's the credit to Dan, the coding train. And if you want to check out that video yourself, I recommend everything on Dan's channel. The coding train is a great resource. Beginner programmer stuff, intermediate, advanced, it's all there, and it's all done in processing or sometimes similar technologies. But that's what we went ahead and implemented here today. And so in the next video, we're going to do another coding challenge, I think, and we're going to go with one that's a little more interactive, a little more complicated, but not by a whole lot. So I'll see you in the next video where we continue on with another coding challenge.